Alrighty. So we share the screen. And like I said, again, I'm repeating it for the online students who missed today's class. This is the exam review set. It's in my announcements, as you can see. You click on this page, it will take you to the page, and this is the file I want you to practice from. There is one more file. If you have time, do that also. With my lecture notes and every question on, not the difficult questions on Affinity, but the starting 10 questions on every Affinity assignments are relevant for the exam. Okay, so you can just click here and the file will show up, or you can download it and solve it. But I'm just gonna pick a question. So everybody has access to their laptops, right? So I'm gonna be referencing to questions using this file, okay? And these notes also I'll post after this class. So this is exam2 exam2 review. Alrighty. So, well, number one topic is 2.3. This will be section 2.3, which is implicit differentiation. And this is the most difficult section for this exam. Implicit differentiation is the most difficult topic that you will learn in this course. Differentiation and related rates. Okay, I'm gonna pick part C of question number 1. Question number 1, part C. So question is the same. You have to find dy by dx. Find dy by dx. And you're given this equation, x e to the power y negative e to the power x equals 0. Okay, and I'm going to differentiate both sides. Just know immediately this will need a product rule because there are two functions. So I will need product rule here. So you must remember product rule, right? What is my f here? What is my g? F is x, g is e to the power y. What is f prime? With respect to x, it's just. What is g prime? Now be careful. The power is not just x. It's the same. You need to do the chain rule. Chain rule for exponential function. Remember that, okay? Now, so this whole thing will need the product rule. So when you write down, you'll have f prime, which is just 1 times g as it is, plus g prime, which is, or f as it is, times g prime, right? And the derivative of e to the power x is just going to be e to the power x. So that term doesn't change. In this question, constant derivative is 0. Now in exam, I will not be too strict. You could leave it here, but I do expect you to at least simplify one step, right? At least leave the y prime terms on one side and move everything without the y prime to the other side. So that's what I expect from you in the exam. So even if you don't completely simplify it, at least make an effort, okay? Unless you are out of time, then I'll still give you full credit if you do the first step correct. So after this, if you just had to get y prime alone, you would just divide by x times ey. And now if you recognize, this was a group problem too, 2 weeks ago. So I've drilled you guys enough with the implicit differentiation problems, right? So practice this. These 3 problems are not enough. Do every problem on Affinity also, and my lecture notes. This clear? Now the second question is the related rates one. So in this question, I'm gonna pick number 3. Number 3 is more important. So number 2 is similar. A similar example has been solved somewhere in my lecture notes. Take a look. Number 3, I want you to focus on 2 things. you are given the average cost here. So you're given the average cost in the function, in the question. And you see, whenever they talk about average cost, any questions? Okay. Emphasis on average, okay? Whenever they talk about average cost, they do put a bar on your C. That's how you know. So you're given the average cost. It is this one. Now you see, this question has made it more simpler, right? They've already written the X as a power. You might not get that in the exam. You might get something like this. So you know how to switch it back to a power. So what do you get? Plus 20 plus 0.00404x dollars per player, where X is the number of CD players manufactured that week. Weekly production is currently 4,000 players. Weekly production is currently 4,000 players. So X equals 4,000. Okay. And the rate of change is increasing at 400. What happens when they say it's increasing? Increasing means dx over dt is positive, right? That's what you have to check from the question. So you have positive 400. Can you find how the average cost is changing? Important question, okay? Just know how to solve this. Important. You're given the average cost, you're given the weekly production, and they also tell you how is it changing. So that's how you know. If they say increasing, decreasing this many players per week, you know they're giving you the rate of change. Rate of change means they're giving you the, well, I should say that this is the rate of change in the number of players. That's why I have X here. Rate of change in number of players, not cost, not anything else, which is X, right? That's why change in X per week. So far good? And because it's increasing, that's why it's positive. Can you find me DC over dt? How the average cost will change? You're differentiating with respect to t. What will be the derivative? Well, first you have to write it as a power, right? D over dt. So I'm going to write the x in the bottom as x to the power -1 plus 20 plus 0.0004 x, right? But I'm differentiating x with respect to t. So you have to do chain rule for x also. So what do you get? I mean, you have to use this guy somewhere, right? And that's how you know you have to multiply by dx over dt. Okay, who's going to do this for me? Okay, we don't have time, so I'm going to do it quickly. So this will be 1. You take the power out, it becomes negative. You subtract 1. Constant will be 0. But am I forgetting one thing? I'm differentiating with respect to t. So I have to do chain rule on x. This is a constant. This will be 0.0004. What is the derivative of x? Just x prime, right? And that's it. So they've given you x, they've given you dx over dt. Plug it in, what do you get? I mean, it must be a big number. 4,000 -2 times 400 plus 0.00. Somebody give me the answer before I finish writing. Times 400. So is it increasing or decreasing? Now, you know, in the like exam 1, I had one line at the end, interpret your answer. That's something you're going to do here also. So the average cost, depending on what is the sign here, can anybody tell me the answer without looking at the answer? Is it positive or negative? I don't see anybody. Jace, do calculation. You have the answer, Tayan. Is it negative? Anybody else? Okay, if it's negative something, then it's the average cost is decreasing at a rate of whatever that number is, okay? At a rate of dollars per week, per player per week. Okay, can everybody do this in the exam? Okay, any questions? Yeah. Yeah. Oh, how do I know? They will tell you, see what is happening to the average cost. So they want to know how is the average cost changing, but they've already given you the rate of change in X per week, right? So they want to know the change per week. Because say I'm measuring something, I'm measuring your speed of a car, and I say I want to measure the speed per month or per hour. So you keep the measuring unit same, right? I'm measuring temperature. I want to keep it Celsius or Fahrenheit. You don't change. So if they're measuring the rate of change in number of players per week, they want you to find the rate of change, which is a good question. Average cost, we want to differentiate with respect to T. That's your hint. Good question actually. Everybody clear? You got minus 2.84? Okay, good. So decreasing by $2.84 per player per week. Okay, looks good. So the radius area, similar concept. In this case, you were given the cost function. Other problems you'll have to make up. So are they talking about area? Are they talking about volume? Now I might just give you the formula in exam. What is the volume? What is the area? But don't bet on that. So remember all the formulas for surface area of a sphere, circle, rectangle, square, stuff like that. Now I'm not going to do the graph problem here. I have to find the relative max. I want to do the calculus problem. Hold on. Oh yes, this is going to be a very important question. Every question will require you to find the critical values, relative maxima, inflection points, intervals of increase, decrease. So that's like a big, expensive question, which will be divided into parts in exam. But you must remember all the steps. So I'm going to start with question number 6, because question number 6 gives me a function. Number 5 is similar. Number 6 is you have to find the critical values of the following function. I'm going to pick part B. Question? No? Okay. I'm going to pick part B. Your function is this guy. 9 times e to the power x cubed negative 75x plus 26. If you can solve part B, you can solve part A. Now, well, how do I find the critical points? That's the question. Find critical points. What is the first step we do? Find derivative, make it 0. Never forget the first step, okay? Memorize it. You find the derivative, make it 0. But this is not just x here. I need the chain rule for exponential. So I'm going to write it out here so that you can refer to the notes. Chain rule of exponential function, which was if you have e to the power something, right? And you want to differentiate it, it's e to the power something, but you multiply by something derivative, right? That's the chain rule. Same thing goes for log. Don't forget the chain rule for log also in exam. Okay, who's going to tell me the derivative? Now this question is tricky. That's why I'm doing it. Somebody? Well, the 9 just stays. E to the power x cubed minus 75x plus 26 stays. I have to multiply by something derivative, which is that. Right? Good, everybody? Anybody wants me to explain again? Okay, good. Now, here's the catch. So don't make your life difficult in exam. This function will never be 0. Will never be 0. Okay, you can just divide by it and get rid of it. Every time you have to find an inflection point, a second derivative, a critical point, and you have e to the power something crazy, Take it common, simplify, divide by it, get rid of that e to the power something, and make your life easy. So I'm going to divide by it. Divide by e to the power blah blah on both sides. Because the right side is just going to be 0, right? And I can take the 9 with the e down. So that's good. Now I'm only left with this guy. Can you solve for x? Divide by 3. What do you get? I mean, I'm getting 25. How many critical points? Good job. Do not forget the negative also, okay? Question? I divided by it on both sides. That was my whole motivation. I divide by the 9e. Okay, I have more problems involving e, I think. So we'll do it again. But every time you have e to the power something crazy, divide by it. The right hand side becomes 0 anyways. Good. I will post this video up so you can watch it again. Now, I've got 2 critical points. Well, this question doesn't ask for anything else, so you stop here. But what if I had given you, well, I guess I have to pick another question, right? Let's just pick number 8. Yeah, this is just asking about the critical points, so we can leave it here. Number 8, let's pick number 8. Number 8, you have a function, it's k of x equals 8x cubed negative 24x plus 12. And you have to find all critical points of f. Part A. Okay, let's just take number 7. That's easier. Okay, I was talking about 8. I picked number 7. That will be shorter, okay? Find me all critical points of the function. And this is an f. So f prime. Well, you know the drill. 24x squared negative 24. And you want to make f prime x equals 0. What does that give me? Minus 24 equals 0. See, you can divide by 24 on both sides. So you get x squared minus 1 equals 0. X squared equals 1 equals plus minus 1, right? So these type of questions are, these are just the critical points. Now I want to find the absolute extrema. What if, let's just add one more step. Find the relative extrema. What would you do? Find the relative extrema. The relative max or min, because absolute is the easy part. How do you find the relative max or min? I want you to memorize those steps. Yeah, Jace. That's the absolute part. No, this one involves the number line. Yeah, so intervals. Okay, good. You gave me the right answer, sorry. So for relative extrema, I'm gonna just write it here so that you remember. Draw the number line and plot critical points. And plot critical points, right? But it's like a lot of steps, but you have to memorize, right? So I've got 3 intervals. Now you pick a test point in each of them. Like pick -2, yeah, that's a good one. Pick 0 here. Pick 2 here. Okay, who's gonna tell me the sign? Now f prime, you just calculated here, right? Is x squared minus 1, is right here. So f prime of -2 will be -2 squared minus 1. It's gonna be positive. F prime of 0, well, that's gonna be negative. and f prime of 2 is going to be positive again, right? Because the derivative is right here. Yes. I'm getting there. No, that's part B. I'm getting there. But relative extrema. So what else do you do? Positive to negative. I'm increasing. I want to pick a different color. I'm increasing and I'm decreasing, right? And what is happening here? I'm decreasing, increasing. Do you recall the happy sad face? If I have a happy face at -1, I have a sad face. What does that mean? Sad face at x equals -1 means it's a relative maximum. I mean, memorize this. There's nothing else I can say. Happy face at this critical point. We only care about the critical points, right? Means it's a relative minimum. Good. Now, what if I asked you the intervals of increase, decrease? Let me make it smaller. What about the intervals of increase? Which increase and decrease? Wherever the f prime is positive, if f prime is positive, what does that tell me about the function? It's increasing, right? That was something you did in exam 1. So which interval my function is increasing? It's -1 and 1 to infinity. And if f prime is 0 is negative in that interval, that means my function is good. So this is all about relative extrema and intervals of increase, decrease. There's nothing else you can tell from the first derivative. And now the part B of question number 7 is finding the absolute extrema. Absolute. Now this is where you want to pay attention, right? So now they've given you endpoints. They have given you some interval, -3 and 2. To find absolute, see, that's the difference. To find absolute extrema. If they are talking about absolute extrema, you know that they will always give you, come on, always give you an interval if they want to talk about absolute extrema. And that's it. You just plug in the endpoints in your function, plug in the other endpoint, plug in the critical points. Well, I've got 2 of them, right? So I plug in -1 and I plug in 1. What is my function value? Now this is the easy part. You just plug in everything and see which one is max or min into the original function, right? This is the original function. I was just going to say that. Original function, right? So who's going to tell me? Is -3, what does that give me? You have to plug in -3 here. It's 24, -3 plus 12, and then I have 8, 2 cube. So whichever one is max or min, you can go from here, right? Anybody, any question? Okay, I'm just going to write it out unless somebody has an answer for me. -132. That looks like a big negative number. So I think that's going to be the minimum, absolute minimum, right? So then you say that this value gives the absolute minimum. Anybody else has answers for the rest of them? If you do it faster. 28. 28 for second one. This will be -8, +24, +12. So 28 I get again, right? What about here? -12 plus 8, I get -4. So clearly I have absolute min at at x equals -3. If I ask you the coordinates in exam, you just write the function value. Absolute max at x equals 2 and x equals -1, right? So you'll have two coordinates, 228 and -128. Good? Because two values are giving me the same number. Question, anyone? Okay, let's talk about number 10. Number 10 is the same question, it's optimization. I have weekly revenue from the sale of X trucker hats and the weekly cost of producing X trucker hats. Find the production level that maximize the weekly profit. So it's like an application problem of same concept. Number 10. And this is important. So I'm given the revenue function, which is -0.025 x squared plus 24x. And I'm given the cost function, which is 16x plus 11. How do you find me the profit? Yes, they want to maximize profit. So what would that be? Profit function will be revenue minus cost. All you have to do is find your profit, differentiate it, find the critical points, plug it in, and that's your value. Now, let's just find the profit. So, well, okay, somebody take out their calculator and, take out your calculators and you have to make it faster. 8x, right? -11. What is the derivative of profit function? Is it 0.05 or 5? 0.0. Yeah, sorry. Okay, good. Where did you get 40x? But I'm subtracting. Revenue minus cost. Okay, don't forget the formula. Now, find me critical points. Phi prime equals 0. You get what? 0.05x equals -8. Question, anybody? Just follow, do the math. Do the math on your own and see if you are following the same steps. You don't have to do exactly what I'm doing. Okay, what is x? 160. 160. So that's the number that will maximize profit. What is the maximum profit? Is profit when you sell 160 hats. I mean, plug it in here. I'm going to leave that for you. Okay. Any questions with this? Same thing you have to do for number 11. The only difference is now the variable have changed. Instead of x, you have a q. That's it. Now, because now this is all the things we can do with first derivative. We can find the critical points. You can find the intervals of increasing, decreasing, like we did here. Or you can find the absolute extrema, or you can find the relative max or min using the happy or sad face. Everything else from now on will require second derivative. So that's what question number 12 is preparing you for. Question number 12 on your papers will be find the second derivative. I'm going to do part A again. So y equals 2e to the power 2x minus 5. Okay, what is y prime? No, you need chain rule. And then multiply by 2. Simplify before you go ahead, do the second derivative, okay? Simplify first. And this is important. especially when you're doing the second derivative. Otherwise, the question will look a lot more difficult than it is. So you get 4e to the power 2x minus 5 times 2 again. So you get 8e to the power 2x minus 5. Now, why do we bother about the second derivative? Because it gives me inflection points and it gives me intervals of concavity. Great. So let me find a nice question for you guys with no graph. Let's just do number 14. I can't see any nicer problem here. Question? Why do we multiply by? That's the chain rule. So this is something, not just x, right? So you have to copy e to the something as it is, multiply by the something derivative. But what is the derivative of this function? Just practice the chain rule for everything, okay? Now, do you want to do number B also? Y equals 7 over x minus 5 ln x. How do I find y derivative? What's the first thing I have to do? Right? What's the first thing I have to do? I have to make it a power. What is the derivative of ln x? Yes, you take the power out, subtract 1. The derivative of ln x is 1 over x. Right? Now, I'm going to make it a power again. Look, I'm not doing anything else. I found the y prime. This is y prime. What is y double prime? Because now the -2 comes out, it makes it positive 14. So these are little things. They're not difficult. You're just applying power rule so far. But practice the negatives and the power coming out and going up, going down. It makes things complicated, right? This is the second derivative. Good. Now I want to talk about finding the intervals of concavity. Number 14 is the question. Doing good? Okay, number 14. Number 14 is you're given a function which is very typical in exam. You have to find the intervals of concavity up or down. So let's just do the steps here. Now it's a lot of steps, so pay attention. G of t is given to be this function, t to the power 4 negative 12 t cubed plus 30t squared plus 9t plus 3. Okay, to find critical points, I find the first derivative, make it 0. To find inflection points, I find the second derivative. First derivative tells me critical points. Second derivative tells me inflection points, right? Okay. So what is the first derivative? All right. You have done like harder things in life. You've done differentiation with exponential and like whatnot before. Expect problems like that in exam. You have to do it again. So differentiate it again. Yeah. Okay, now to find the inflection points, I have to make the second derivative equal to 0. So what do I get? I mean, you can apply the quadratic formula or you can split the middle term, factor this, you do whatever you want. Find me t. Oh, good job. I would divide by 12 on both sides to make it easy. First, I mean, I would divide the equation, right? To make it easy. Okay, so what do I get? I get t squared negative 6t plus 5 equals 0. Use quadratic formula. If you forget about it, it's this one. You will not get this formula in exam, so you must memorize this one. I mean, you can split the middle term. Did you say 1 and 5? Okay, I trust you guys. So these two are my inflection points. Now the process to find the intervals of concavity is the same as you would do with critical points. You draw your number line again. This is the second step. So draw your number line. You have negative infinity, you have positive infinity, you have 1 here, you have 5 here. Just like you were checking the sign of f prime, here you're checking the prime sign of double prime. So like pick a number here. I would pick 0 if I were you. Pick a number here. I mean, easy ones, you know. Well, you are allowed a calculator, so. Okay. Who's going to tell me what is G prime? So if I pick 0, I get positive. If I pick 4, I get negative. If I pick 10, I get positive again. So any questions you ask me? Yes. Yeah, not random numbers. It should be in this interval. Like anywhere in between those intervals. Yes. Pick any number you like. Yeah. In G double prime, okay? Check sign of G double prime. That's the difference. Before we were checking the first derivative. Now the only difference is now we're checking the second derivative. So concave up on where it's positive. So 2, 1. It's 2 intervals where it's going to be concave up. And I do recommend to read my lecture notes too. Just print those out and just give them a read. You know, you don't have to solve the examples, just read through them. I have written a few things there. Okay, so this was all about up and down, find points of inflection, blah, blah. Acceleration, one more thing I wanted to know is number 16. If I give you, this is just an application of the second derivative. If I give you the position, questions so far? If I give you the position vector, this is root t plus 4t square. The velocity, just memorize this also. I know, a lot to memorize here. The velocity is the derivative of position vector. What is that? Well, first I have to make it a power, right? So what is velocity? The derivative of position vector. You take the power out, subtract 1. This is just simple. What is acceleration? Anybody who drives a car should know. What is acceleration? Faster? Yeah, how fast is the velocity changing, or how slow is the velocity changing? So you're basically looking for the derivative of velocity, right? But what was velocity to begin with? It was the derivative of the position vector. So you see, it's technically the higher order derivative. Can you find it again? Question? Doing good so far? -1. Okay, ask me. So velocity is the rate of change in your position, right? Acceleration is the rate of change in velocity, like you said. But velocity is this guy. So what is acceleration? Technically, is the double derivative of position. Yes. Oh, sorry, that's not supposed to be there. Oopsie. I see. Is that confusing you? My bad. Okay, now it makes sense. Okay, that's why you were going crazy? No, not here. It's just asking you to find the particle's acceleration as a function of time t. And that's it. So the particle's acceleration as a function of time t is going to be this guy. If they asked you find the acceleration at 10 seconds, what then you plug in 10. Okay, good. You know it. Good job. Okay, so I have two formulas for you. So this was the this takes care of the optimization part, right? Now we had this marginal analysis 3.3 before the elasticity. Now I know the math for this exam is not going to be too tedious, but there will be a lot of things to memorize, unfortunately. So let's talk about the last topic, which is not last, second last topic, which is number 17. I gave you two formulas in the lecture notes, right? Who can tell me the formula for linearization of a function? We were basically approximating it. Can you tell me the formula, because you need to memorize it? Yeah, it uses the tangent equation. Now these are the two formulas that I want you to memorize for the following from problems number 17 up to 20. Okay, come on, chop chop. Somebody. Yeah, so f of a equals f prime of x times, it's just the equation of tangent line, right? No, was it f prime or f of a? Just f of a. Right? It comes from the equation of tangent line, but I don't want to confuse you more. So just memorize this. What was the differential formula? Approximately. See, I cannot remember this for the life of me. But I did remember this when I was writing this exam many years ago. Okay, if you remember these two formulas, then question number 17 is just a no-brainer. You are supposed to, well, I don't want to solve number 17 because that's the exact one. Because you can match your answers, right? I want to solve a different problem. Find 17 will be exactly the same as this. I want to give you more problems to solve. Find the linearization of this function given by this function, the fourth root of z at z equals 2. What do you do? Well, you need the derivative here. So first things first, you write the function as z to the power 1 over 4, right? What is the derivative of z? Negative 3 over 4. And because they're interested in z equals 2, so the linearization of z at 2 will be, well, plug in 2 here, what do you get? I'm getting 1 over 4, well, 2 to the power. You don't have to simplify this, right? G of 2. So this is just copying steps down for every problem, but you have to differentiate, plug in the given point, then apply everything in one formula. What do you get? So linearization, when I plug in everything in the formula above, it will be this. 1 over 4, 2 to the power negative 3 over 4 times z minus 2, right? So that's why I picked a different variable, so that you just have more things to practice. Good? Yes. You can leave it like that. Absolutely. Now, do you remember if I give you cost and I say find me marginal cost, what will you do? differentiated, right? So just remember that if cost function number 19 it's really straightforward. Cost function is this, revenue function is this. Okay, it was the very last page of our lecture notes. What is my profit function? Exactly. So you get 4x cubed plus 2x plus 3. Make sure you put a bracket on your after the negative sign so you have the right signs in exam. So what is marginal cost? Is just the derivative. What is marginal revenue? Just the derivative. What is marginal profit? Just the derivative. Right? Do not ask me in exam what is marginal cost. I will not answer that. Good, I'm telling you right now. Plus 2. And then marginal profit will be 12x squared plus 2 minus 16x. Good. Okay, now everybody's favorite topic. And then, yeah, sure, question, yes. Marginal cost, revenue, profit, what does that tell us? It just tells you how much it will cost, or how much money you'll make, or how much profit you'll make if you sell one more item after X number of items. Technically, marginal cost that's the formula for it. So the cost for that one more item, right? So if I was asking you question, yes, sorry. I'm gonna post it tonight. These notes will be posted, but you see what I'm talking about. So it will be a question exactly in exam. I will ask you, interpret your answer. This is what marginal cost revenue is telling you. If you sell one more item, how much profit you'll make, right? So you just plug it in the function, that's what it tells you. Good. It's more economics thing, but you get it, right? Okay, elasticity, our last topic, then we'll be done. Who can tell me the equation for elasticity? I think everybody liked that topic. Is given by, I mean, you have to memorize this for the exam. Okay, the sooner you do it, the better. Over, right? Where P is the price function, which will be given in the question, and Q is the demand function, right? Because that's what they ask you. How is the demand changing? Is the demand increasing, decreasing, if you increase the price or decrease the price? Now, there were 3 things to remember here. What if the elasticity is less than 1? What does that mean? Raise the price, right, to increase the revenue. So remember this. So increase price to increase revenue, right? That's how you should memorize this. If it's more than 1, it's elastic. Then you have too high price, right? We did a bunch of examples in class. I'm not going to go over that again. But decrease price to increase revenue, right? And what gives you maximum revenue? That's the magical number. That's the magical E equals 1, which gives me unit elastic. That's what you will be looking for most of the time. Maximize the revenue. They change at the same pace. Okay. Now, so it means that if you increase the price, you will not have a lot of decrease in the demand, and you will still have the maximum revenue. Now, 21, 22 are conceptual questions. You can do them easy peasy. Number 23 is what I'm more interested in. Well, number 23 and 24 are the same. Let's just do number 24 because that's more complicated, right? Number 24. So you're given the monthly sales of an item is given by this. So you're given the demand function. 24 is on your PDF. Q is equal to 90 minus P squared. Find the price elasticity of the demand function in terms of the price. Well, first you have to find Q prime. How do you find Q prime? This is chain rule of power rule. Do not foil the bracket here. It's easier than that. Do you remember that? If you have something to the power n and you want to differentiate that, what do? You take the power out, copy something, reduce 1, multiply by something derivative, right? We've been doing this from exam 1 now. Everybody recalls? Okay, good. So take the power out, subtract 1, multiply by the derivative is just 1. Wait, did I forget negative? No. Good. So what is Q prime? It's negative 2 times 90 minus P. So now you have Q prime. What is the elasticity function? It was negative Q prime times. What happened? Question? I mean, this is something you have to memorize, right? Okay, so plug in Q prime. What do you get? Plug in P. Well, P is just P, right? That's the price function. Plug in Q. You get 90 minus P squared. Good. You can simplify this or leave it here. That's the answer. That's the elasticity function in terms of price. I could simplify it and get this. All I did is cancel that with that power. I canceled this with this power. So this is part A. This is all they want in part A. Good. If I give you the demand function, can you give me the elasticity function? Good. Part B is find the elasticity at the price of 33. Okay, that's like easy peasy lemon squeezy. You're just finding it at 33. Okay, who's gonna find it for me? Quickly, I wanna go home. What do you get? No, give me decimal. That doesn't sound right. Somebody else, it should be less than 57. One. Okay, so it is. See, I forgot. I had a negative already, right? You see you see me screwing up? Don't be me in exam. Yeah, so you get more than 1. What happens if your elasticity is more than 1? Is it elastic, inelastic? Elastic, and that's a bad thing, right? What should the manufacturer do? Decrease price to increase revenue. Just remember that, okay? Now, what price will maximize the revenue? That's the important part. Number D, and that's important. How do you find the maximum price, the maximum revenue? Set equals to 1. Good job. And solve it. 2p over 90 minus p equals 1. So you get 2p equals 90 minus p. You get 3p equals 90 P equals 30. So this price will maximize the revenue. Can you find me the maximum revenue? Yeah, what do? You multiply the price by the number of items sold, right? Price is 30. Number of items sold is a function. So 90 minus 30 squared, right? Because demand is dependent on the price of the item. So that is your maximum revenue. Good? That's it. So this, just study this, study my lecture notes, do the first 5 to 10 problems on Affinity for 2.3 up to 3.4, and you should be good for the exam. Exam is Monday, October 21st. Okay, good luck, everybody.